All right, let's look at this first example. This is the Oscars, Best Actress versus Best Actor. So consider how we treat women and men differently based on their age. For each year of the Oscars, that year's Best Actress and Best Actor were recorded. Now note that Best Actress and Actor are a matched pair in the same year. So the age of the best actress and the age of the best actor, they're both dependent on the year that the Oscars were given. So both are dependent on the specific year. Okay, below is a random sample of all of the Oscar results. So of all the years that the Oscars the Oscar ceremony was performed, okay, we've taken just a few a sampling of that data. So, with a 95% confidence level, test the claim that for the population of ages of best actresses and best actors, the age differences between women and men have a mean less than zero. This indicates that best actresses are generally younger than best actors, right? So, to kind of help you understand, how this is being set up, because it's really hard sometimes to translate, a literal claim into a mathematical equation. Okay, doing that translation is difficult. So here, that's kind of what I'm focusing on here down below. So for example, if we had said that the mean age of the actress is equal to the mean age of the actor, and we moved this mean age of the actor over to the other side by subtracting from both sides, then we'd end up with this equality here. Mu actress minus mu actor equals 0. Now, if instead we wanted to make the claim that the mean age of the actresses is less than the mean age of the actor, and we move the mean age of the actor to the other side of this inequality, then we get the mean age of the actress minus the mean age of the actor is less than 0. So here, when we say the age difference between women and men have a mean less than 0, so here's the difference between the mean age of women and men, or actresses and actors, being less than 0. So by saying this, we're doing a hypothesis test that the Oscars is biased towards younger women. That's what we're claiming, okay? That this is the case, that Oscar winners typically for women are younger and men are older. So we're going to test and see if the data, either, confirms or rejects that. And confirms really isn't the right way to say it, but this will be an alternate hypothesis because of this inequality. All right. So this is actually what we're looking for here. Okay, so let me highlight this. And I'm stating this because this is how we're going to want to input this, like, for example, in the NumWorks hypothesis test. All right. All right, so let's look at step 1. So this is to identify our givens. So here we're going to be talking about the mean of the differences is less than 0. All right, and up above, I said that the mean age of the actress minus the mean age of the actor is less than 0. But we're treating these two as though it was 1. So when we take the list of actress ages and we subtract from them the mean age of actors, we're going to get a single column of data. And so we're going to be considering the mean of the differences. And we want to see if the mean of the differences is less than 0. Okay, this is our original claim. Okay, I'm trying to scroll down a little bit so I have some more room to write. There we go. I want to erase. Okay. All right, so what else were we given? So because the population standard deviation of the differences is unknown, we're therefore going to be using a student's t-distribution. And since we're using a student's t-distribution, we need to know degrees of freedom. And degrees of freedom is equal to sample size minus 1. All right, so what's the sample size? Well, let's see, we've got 2, 4, 6, 8, 10. So we have a sample size of 10, which means the degrees of freedom is going to be 10 minus 1, or 9. All right, that's good. Now, they did give us a confidence level, so we have a confidence level of 95%. So we have a confidence level of 95%, which means we're going to have a significance level of 0.05. Okay, so I think we've got enough here. So step 2 is to set up the null and the alternate hypotheses. So this is our original claim. All right, so what would be the complement of this? So if the mean of the differences is less than 0, the complement will be greater than or equal to. And so that'll be our null. This will be our alternate. Let me scroll down. Here we go. And so because the alternate hypothesis is less than, it looks like an arrow pointing to the left. So we're going to be dealing with a left-tailed distribution. All right, so that is everything that we need to do in step 2. Step 3 is to calculate the, no. We want to calculate the test statistic. So we want t-test, and we need the p-value. Degrees of freedom, we already know, is 9. All right, so to do that, so because this involves a lot more calculator work, and this is an example, I went ahead and I kind of put screenshots, of these functions for both Texas Instruments and NumWorks that you could use. All right, so I'll kind of walk through doing both of these things. So first of all, we want to put the actress ages in list 1, the actor ages in list 2, and then we'll do the subtraction. All right, so let's go ahead and do that first. So I've gone ahead and I've put in these values. So you can pause this video if you haven't done this yet and you want to do this on your own. So I'm going to go over to list 3, and I want to program list 3 see down here, so that I'm going to have list one minus second, then two, list two. And as soon as I hit enter, list three is a list of my age differences. All right. Now let's go into the numWorks calculator and we'll do a very similar thing. So I put the data into the statistics app. So this value one column, these are my actress ages. This V2 column, these are my actor ages. And so V3 is going to be V1 minus V2. So with this column heading selected, I'm going to click OK. I want to fill this with a formula. And if I scroll down to the bottom, the last one is V1 plus V2. So that's kind of nice because now all we need to do is change this plus to a minus, and now we've got V1 minus V2, right? So the age of the actress minus the age of the actor is going to give us a list of age differences. So if I click OK, you can see here we're getting the same values that we got over here with the Texas Instruments calculator. So V3 is the one that we're going to use here on the numWorks, and L3 is what we're going to use here on the Texas Instruments. So, we've done this part with Texas Instruments, and we've done up to this part here with the numWorks calculator. All right, now these instructions actually were on a version of the calculator which didn't allow you to use data yet. So what I did with this numWorks calculator is I went into the stats tab and I recorded X bar, S, and we know what N is. And in the past, this calculator actually didn't give you this, didn't give you the opportunity to put in values, okay? But I'll show you how to do that. All right, so now we need to run a t-test. So with the Texas Instruments calculator, we want to hit stat, go to tests. We want to do a t-test. So this is a one sample mean t-test. Now instead of stats, we're going to click on data. Okay, now this mu naught, this is the difference we're looking for, and that was 0. Our list is in list 3, so I want to hit second and 3 to put it in list 3. And the sign of my alternate hypothesis is going to be less than 0. All right. Now with the numWorks calculator, now that we have this information put in, let's go back home. Now we want to go to the inference app because that's where we do statistical hypothesis tests. I want to do a test, and we want a one mean test, a student's t-test, and let's see here. So that's going to be 0. And the alternate hypothesis is that the mean of the differences is less than 0. So we're good. Okay, so previous versions of the operating system on the numWorks didn't offer you these two options, but now it does. So now we can put use a data set. And then here with the data set, if I click OK, I can put that my difference list is in V3, N3. So notice these are my only options here. This is what I was referring to earlier of kind of not using the regression app, because the regression app on the numWorks calculator has columns called X1 and Y1. And I tried this. I put these same values in X1 and Y1, and it didn't offer X1 and Y1 as an option here. Okay, so the inference app, as when it's prompting you for a data set is only looking in the statistics app tables. Okay. So I'm going to choose V3 because that is the list of my differences. And remember, you have to scroll all the way to the bottom in order to progress. Okay, so we do have a significance level of 0.05. So we'll hit next. All right, so it gives us the sample mean, the sample standard deviation, and the sample size. And it also gives us our test statistic and our p-value. So this is what we're going to write down. Over here with the Texas Instruments, I'll hit calculate, and you can see we get the exact same values. All right, so this negative 2.60894 and an area of 0.014. That's these values here in the t-test, and that's these values here in the t-test for both calculators. All right, so let's go ahead and sketch. I left some room up here, just barely enough. Let's do a sketch. I'll probably need a little bit more room than that. Of our student's t distribution, which has 0 here in the center. We said that this was going to be left-tailed. So we have a negative t critical value that we don't know yet. The area over the tail is the reject the null. The area over the confidence level is fail to reject the null. This area here, this is our significance level of 0.05. All right. Yeah, we'll put those values in. Let's get our critical value first. So for that, we need to use these functions. So with inverse t, we're going to have an area of 0.05 with 9 degrees of freedom. And we're going to use a student's t distribution under the distribution app. So we'll put 9 degrees of freedom, area to the left of 0.05. So let's do that really quick. You know, yeah, I've got it down here. Let me just highlight that. All right, we'll put that in here in a minute. Okay, so let's calculate this critical value. So we want to go to stat. I'm sorry, not stat. We want to go to the distributions functions, go to inverse t. Okay, remember it calculates the area from the left, so we'll be fine. 9 degrees of freedom. Hit paste. Negative 1.833. With the numworks calculator, let me go home, go to distributions. I'm going to go to the student's t. We have 9 degrees of freedom. Area to the left with an area of 0.05 or 5%. And we get negative 1.833. So negative, this is what we expect. So let's go back. So we're getting a critical value of negative 1.833. Okay, so where is our test statistic? Our test statistic is at negative 2.6. So that's somewhere out here. So our t-test statistic is negative 2.6, and it keeps going. And if we go up from this point, that's clearly rejecting the null as a result. And this area adjacent to it is our p-value, and that is 0.014. So comparing apples to apples, okay, that's telling us to reject the null. But if we compare oranges to oranges, area to area, if the p is smaller, then reject the null. So 0.014 is smaller than 0.05. So that's telling us to also reject the null. So coming down here, step 5, that was step 4. This is where we put down our results and write our conclusion. So we are going to reject the null hypothesis, and the alternate hypothesis was our original claim. So we are rejecting the null, and the alternate was the original claim. So where those two intersect, this is our outcome. So now we just have to formally write this as a conclusion. So let's see here. We're going to say there is sufficient evidence to support the claim that the differences between the ages of best actresses and best actors is significantly less than 0, showing the mean age of best actresses is less than best actor, and that is with a 95% confidence level. And this is our conclusion. All right. So we're using the process of an earlier hypothesis test, just doing a single mean t-test, but we're applying it to having two sample means and looking at the difference between those two. So again, just going through the same hypothesis test process, like I said, the firmware of the numWorks calculator, the operating system has changed a little bit. So we don't need to find the values and write them down. But now we can just go ahead and directly put those values in. Another way I thought of using the numWorks calculator, so you can stop now if you're done, but let me show you one more thing with the numWorks calculator that I thought of that also might work for a t-test. So earlier, I had said that you could use, the regression app. Okay, this is the list of actress ages. This is the list of actor ages. And it's a little easier to see these actually in the regression app. And so if I want to calculate the differences, I could just come over here, click OK, but fill with a formula. And then I could put x1 minus y1. And I can see the list of differences here. A little bit easier than in the regression app. But remember, I can't put x2 as a data set in the t-test, hypothesis test. But what I can do now, I think, I'm winging it here, is in this statistics app, I could just set V1 to be equal to X2. So if I come up here and I click OK, and I say fill with a formula, and now I can set V1 equal to X2. This was that list of differences that I had in the regression app. And I'm hoping this works. Let's hit execute. There we go. All right. And so now when I go to the inference, and let me back out of this, right? And I do a one mean t-test, and I put use a data set, I can now use this first one. So maybe in a way that complicates it, but I thought maybe it might be easier to maybe see the values a little closer together and the differences a little close together than it was when we were in the statistics app doing the same thing, and you had to scroll over quite a bit to see the differences. I don't know. I just showed it works. Use whichever way works best for you, but I just kind of wanted to show you, how you can kind of reference things between different apps. Okay, let me know if you have any questions.